Hi everybody. In this video, we are going to start things off with a lesson introduction, and this lesson is going to be the angle sum and difference identities. So before we get started, we should recall how to say these Greek letters, because for some reason there's a handful of people who either straight up forgot or weirdly messed them up. So let's just go over what they are. This one over here that looks like a little fish, that is alpha. Weirdly, people want to say beta because I guess there's beta fish. And then from there we have beta over here. That's beta. And it looks like a capital B, and that right there looks like a lowercase a, right? Can you kind of see A and B? All right. So alpha and beta, alphabet, right? So where we get our alphabet from. Now, these are Greek letters. We usually use theta when we're describing an unknown angle. But for this lesson, we are going to use alpha and beta because we are going to talk about the sum and difference of two angles. Now, it's possible that alpha is 45 degrees and beta is 45 degrees. But it's also possible that alpha is 45 degrees and beta is 30 degrees. They don't have to be the same. Also keep in mind when we might reference the fundamental identities, which were the reciprocal, quotient, and Pythagorean identities. You can only simplify and apply those identities when the angle, whether it be theta, alpha, beta, x, y, z, whatever, is the same for everything involved. And we'll see that in a few examples. So first thing we're going to do is we're going to write down a few rules. And actually what I'm going to do is everywhere that you have a plus sign, I want you to make it plus minus for all of these. I was thinking about just writing them down and then asking you guys to press pause and copy them all down. But then I decided if I write them along with you, then I can better gauge how long the video is and how long everything takes. So I did lay out a little bit just so you could get your page started, because I know sometimes you don't necessarily plan for enough space, and that's always an issue. So let's get started. So if you have this written, the parentheses matter, everything matters. Do not get lazy. Do not try to take shortcuts. You're going to change the problem and you're going to mess things up there. So I'm just going to give you these identities for now as rules, formula looking things. They're going to be these little equation guys. You're going to write them down and you're going to work on memorizing them. We're going to do a little warm up. We're going to do some guided examples. And at the end of the guided examples, we're going to come full circle. We're going to come back and we're going to look at the rules again. And I'm going to go over a few tricks for memorizing them because you'll be a little bit more comfortable and familiar with them. All right? I think I've stalled long enough. Hopefully we are ready to write these down. The sign of alpha plus or minus beta will be equal to the sign of alpha times the cosine of beta plus or minus. If plus is involved, if it's adding, then plus is in the identity on the right side. If it's minus, then we use minus. Cosine alpha times the sine of beta. Now, I didn't put a dot there. I did put a dot there. They're both multiply. All right? Don't forget that. Now we have cosine. Cosine of alpha plus minus beta. Cosine, alpha, cosine, beta. Find that, multiply your answer. Minus plus. So if this is plus, this is minus. And if this is minus, this is plus. Sine alpha, sine beta. That was identity number 2. Next one, tangent. Now here I'm going to kind of show you one way to do tangent, which isn't really the best way, but if you have limited space for memorizing stuff and you only really want to memorize 2 things, well, guess what? You can use those 2 things to figure out everything else because of the fundamental identities. Since tangent is equal to sine over cosine, that means tan of alpha plus minus beta will equal the sine of alpha plus minus beta over the cosine of alpha plus minus beta. So if you don't want to memorize the nicer tan rule and you memorized these two, well, I guess you could use the sine alpha cosine beta plus minus cosine alpha sine beta over cosine alpha cosine beta minus plus sine alpha sine beta. If you were typing this into, say, like Desmos or a calculator somewhere or whatever, you're going to go a little heavy on the parentheses. When we get to examples where we use parentheses, I will definitely demonstrate and show you, but you definitely would put parentheses around the whole denominator. Whenever you have a sum or a difference in your denominator, make sure you go nuts with those parentheses, and really the same with the numerator. If you have a sum or a difference in your numerator, really make sure you put parentheses there. Now, like I said, to me, this is like sort of a cop-out, but it is a good option, and there's nothing wrong with it. But underneath, I'm going to give you now the nicer, more clean tangent, angle, sum, or difference identity. So that will look similar, but you'll see it's a little cleaner. This will be tangent alpha plus or minus tangent beta over 1 minus plus tan alpha tan beta. So maybe, like, stare at that for a minute and just kind of try to draw, make some comparisons. What do they have in common? How are they different from this and this? Think about that. So if you need a little bit more time to write all of this down, go ahead and press pause. And if you are done writing this down, we're going to move on. We're going to do a little bit of a warm up. And what you're going to notice is, like, it's going to be like a game show or like, this is your life. Well, we're about to go back and you're going to see everything that we've done recently come back and get applied with these new identities that we're tacking on to the ones we had before. So remember, we had P, Q, and R. P was Pythagorean, Q, quotient, R was reciprocal. Now we're on S, sum and difference identity. So we're on those now. It's just coincidence that it went P, Q, R, and S. It's not really a thing or anything. Okay, so hopefully you're ready. Let's check out our warm-up example. So to warm up, I would like us to verify the following. If you remember what the word verify means, we use that when we have an established identity in front of us. Something is an identity if the left side and the right side are equivalent. They are the same thing. If I try to solve for alpha or beta or whatever variables involved, I would end up having more or less, basically, if you do it correctly, you'll have everything kind of clean and cancel out, reduce down, simplify, gone until you have something like 1 equals 1 or tan theta equals tan theta or something along those lines, and there's nothing else you could do. And that's because it is true, and you can't solve for the case when it's true because it's always true. We verify by manipulating one side of the equal sign, changing one side until it matches the other side of the equal sign. So I'm going to go ahead and demonstrate this for you right now. However, I do think that if you think you're pretty good at this and feel ambitious, I would press pause and go ahead and try to do this on your own. See what you come up with. But I don't want you doing this using the transitive property and be like, well, this is equal to sine alpha plus minus beta. This is equal to cosine of alpha plus minus beta. This is equal to tan, blah, blah, blah. No, don't do it that way. I want you to change this without, pretend you never knew the other identities on the other page. Pretend they don't exist. I want you to manipulate this till it looks like that or vice versa. All right? And then once you're done, you come back, press play, and do it with me, or check if you did it correctly. And otherwise, I'm going to do it right now. So let's get started. Whenever I have an identity that looks to be a little heavy, overwhelming, busy, a lot of stuff going on, I always try to hone in on, in a case like this, the 1. If there's a 1 involved, it makes it really easy for you, especially in a case like this one, where you have something plus minus something, something plus minus something. The numerators are structured the same way. The denominator, you have an expression minus plus an expression. Expression minus plus an expression. They're structured the same way. This is going to be like a 1.5 step identity. The 1, that's the money spot right there. That is the easiest place to tell what changed from one case to the other. It's usually through some sort of a multiplication or division, which is multiplication. So I have, where the cosine alpha, cosine beta is, I have a 1. So how can I change this? I like to change the more complicated thing till it turns into the simpler one. How can I change this into a 1? All right, well, I have to treat my whole fraction the same. So the top and the bottom will need to get multiplied or divided by the same number. So I'm going to multiply the top. I'm going to multiply the bottom. What am I going to multiply by? I need it to become a 1. So I'm going to multiply by 1 over cosine alpha, cosine beta, and the same thing down here. 1 over cosine alpha, cosine beta. If you said to yourself, you're going to divide every expression by cosine alpha, cosine beta, then sure, that's okay. I'm just showing it as multiplying by the reciprocal, I suppose you could say. Look at it that way. So it's the same as dividing them all. Now, this goes here, here, and this one goes here and here. Full expressions. So I have to send this off to 4 places. We have to do it on top and bottom because anything over itself is 1. The multiplicative identity, so you're really multiplying by 1. You're changing the appearance, not the value. Now if I distribute this, I'm going to show work. You might not have to next time, but I have sine alpha, cosine beta, and it's really over cosine alpha, cosine beta. There's the plus minus. Continue. Don't forget to distribute the whole time. Don't zone out. Don't only give it to the first term. You know, like everything gets it. Okay, so now I have cosine alpha sine beta over cosine alpha cosine beta. Take your time. Write it down. Rewind it 30 seconds. Watch it again if you're confused, okay? It's not a lot. You're just maybe getting overwhelmed because there's a lot of letters and symbols on the screen. Relax. It's fine. Rewind it a little. Watch and listen again, okay? Do it. Do it if you're confused. Don't be a weenie. Cosine alpha cosine beta, that was already there, times 1 over something, so it's the same as dividing by that thing. Cosine alpha, cosine beta, and right here you could see this is something over itself. It will become a 1. There's the 1. It's going to become, minus plus. Don't assume anything. Make sure you're writing down what it says, not what you wish it said. Sine alpha, sine beta, over cosine alpha, cosine beta. Now equals this guy right over here. So tan alpha plus minus tan beta over 1 minus plus tan alpha tan beta. Not everyone's going to write the right side every time. For right now I am. So just to reinforce it a little bit, was 1 over that, right? 1 over that. And this is where it is now. It's right here. Okay. Now, what I mentioned earlier, they have to have the same angle. You could only reduce or simplify or apply other identities if they have the same angle, the same variable for the angle. So we have cosine alpha over here. Sine alpha over cosine alpha, that can reduce into something, or not reduce so much as we can use an identity to rewrite that differently. This cosine beta over cosine beta, they have the same angle. We could work them together. Those can work together. Everything that has the same. Now, they're not always going to be written the right way for you. You might not stack them above each other. That's why you want to think ahead. You want to think about the next steps and whatnot. So with that in mind, cosine beta over cosine beta, that reduced or simplified to 1. Same with cosine alpha over cosine alpha, became a 1. Here and here as well, 1 and 1. These are all being multiplied. And that's it with the 1s. Now, sine alpha over cosine alpha, sine over cosine, so that actually will become tangent of alpha. And tangent alpha times 1 is just tangent alpha. Okay. Plus minus sine beta over cosine beta, that's tan beta. Think about it. Sine, cosine, they're both beta. Keep the beta. 1 times 1 is 1, minus plus sine over cosine, both alpha, both beta. Tan alpha, tan beta. And we were trying to verify that it was equal to this. Winner, winner, chicken dinner, twinsies. We are finito. So that was just a warm-up, a throwback to when we were doing identities and verifying identities, and we were really only implementing the reciprocal, quotient, and Pythagorean. And now we're going to scroll in and start introducing new identities. So right now we're working with the angle sum and difference identities. Again, you should have those written in your notes already for the introduction lesson. Now, what the heck are we going to do with those? You know, like, are we going to apply them, just memorize them? A lot of things. So we're going to solve equations with them. We're going to simplify expressions with them. We just verified an identity with them. We're going to evaluate them. There's a lot of these words that you see in directions that we're going to implement with these identities over here. Keep in mind, alpha and beta are variables for our angles. Our angles could be given to us in degrees, or they can be given to us in radians. So one more thing before we wrap up today's lesson intro. A while back we had an assignment and I asked you to do a few things for me. I asked you to do pi over 6 plus pi over 4, pi over 4 plus pi over 3, pi over 4 minus pi over 6. Things like that. I think I use different angles. But do you remember how to do that? I mean, you should. We were just graphing trig, so it's pretty similar to things that look like that. Remember, we would have our h, that was our starting point. Then we would figure out the period, the quarter period, and then we had to add that quarter period to h over and over again, right? And sometimes when you went to go add or subtract the quarter period to your h value, you didn't have a common denominator, so you'd have to find one. Well, it might not be a bad idea to figure these out, put them in your notebook with a little star next to them. Maybe even, let's throw over here pi over 3 minus pi over 4. These 4 examples, what is the least common denominator for these? Finish these up. Oops, minus. Finish these up, simplify nicely, keep them handy. Put them somewhere in your notebook, like on the, inside that front cover or on top of the page that, you look at all the time. I don't know. And you're going to see why these are useful. So if you could just finish that up before you start your next video. The next video is going to be 5 guided examples. I asked you what's the common denominator, and I sit here filling in the 12s. Well, it's 12, guys. I can't help myself. So we're going to pick up with this one. If you are making a pinky promise that you will memorize these for me, press the thumbs up. If you are not going to memorize them and just going to look at them all the time, then click on the thumbs down. I hope you memorize them. I hope you do. And we're going to go over some tricks after the guided examples. I'll see you in the next video.